the next batch of equations. And you see that all these fraction equations are actually of the form, well, a over b equals c over d, so we can solve them with the cross rule. Actually, are there any fractional equations that come up? Yes, at the end of the exercise, g through h or f through h actually contain more than just two fractions that are equal. They contain three fractions or other things. So we will we will actually have to make those equations under a common denominator. But for d and e, here we can just keep on applying the cross rule. So let's see, before I do that, I see already that I can simplify the right-hand side. I can reduce it. There's a factor of 3, and down here. And this magically makes appear a factor of x plus 2, which is also on the left-hand side. By the way, the domain is r except minus 2. And, well, we need a factor of 3 here. Actually, let's solve this with the cross rule, just to see a bit the difference. So we just have 2x plus 19 equals 3 times x plus 2, whoops, not equals, times 3 times x plus 2 equals x plus 2, 3 times 23, but I actually intended to reduce the 3, so you can reduce it either in the fraction or in this new equation. And we see a common factor of x plus 2, so we can divide it out, but just bear in mind that x plus 2 could be 0. This is a special case. This thing here, this equation only holds if x plus 2 is not 0. So let's solve this. 2x equals 4, so x equals 2. And here we get x equals minus 2. Is that right? Yes, yes. And we see, however, that minus 2 is extraneous. So the actual set of solutions is just the number 2. With number E, also look at the fractions. They have all the numbers in the equation have lots of common factors: 9 and 18, 15 and 3, 16 and 8. So let's factor the fractions, and then we can reduce, and this already makes the numbers much smaller. And here it's 5. And here, don't forget the minus sign. And also, wait, let's reduce first. Actually, we can only reduce on the left-hand side. Ah, yes, we can reduce on the right-hand side, on the left, on this side. That is a 3. Sorry. And just before we go any further, take a look at this 2 minus x. This is almost the same than x minus 2, except for the order of the operands. But this is actually what this minus sign is all about. And down here, 5x plus 1 is the same as 1 plus 5x. So we can, well, first of all, let's look at the domain. Of course, what's the domain? 5x plus 1 can't be 0, so 5x can't be minus 1. So minus 1/5 is forbidden. And now we can multiply it out then safely. And we are left with 3 times x minus 2 equals 2 times x minus 2. And now we can divide out x minus 2 if x minus 2 is not 0. This gives us 3 equals 2. If x minus 2 is 0, well, we get the solution x equals 2. 3x equals 2 obviously has no solutions. And this here is the valid solution. It's not extraneous, it is in the domain. So there we go. Finally, for number F, can maybe put that here. So these fractions do not have a common denominator as they stand there, but we have to find it. And since they have no common factors, we just have to multiply them together. So the first fraction needs a factor of x and x plus 1. The second one needs a factor of x minus 1, x plus 1. And the third one needs a factor of x and x minus 1. And of course, the domain is anything that does not make the denominator 0, so we exclude the numbers 1, 0, and minus 1. So now we can safely multiply out this common denominator because we've made sure that it can never be 0 once we have excluded these three numbers. So we are left with x plus 1 plus x minus 1, x plus 1 equals 2x, x minus 1. And this is a polynomial equation. We solve it by expanding and then hopefully factoring. So this is x squared plus x, this is x squared minus 1, and let me also put this thing here on the left-hand side, because we want to be able to apply the zero product rule to x squared minus 2x, and we can expand the brackets with plus here. And now what do we see? We see that the factors x squared vanish, and we get x plus 2x minus 1 equals 0, so x equals 1/3. This is in the domain, so it's a valid solution.